right, great. Thank you for joining me today. And we are going to talk some more about multiplication and multiplicative thinking. And the session I did 2 weeks ago, I kind of left off at the end there. So I'm kind of picking up right there where I left off. All right, that's me. If you ever need to contact me, if you're watching this later on and you want to get involved in the conversation, please feel free to email me. And there is our website. If all the past sessions, 9 weeks was a long time ago, we can go back and look at all the sessions and the great resources that are available on our website. And you need to be watching our website for all the new innovative things that we have coming up here in July. So today's agenda, we're going to be looking, of course, at the standards and the research behind multiplicative thinking. Then we're going to talk about some manipulatives, some N tiles, and the L cover. And those are some resources that I have placed in your resource packet that you can open up and look through. I have an L cover for you and an array model, and I'm going to be explaining some more about that here in just a moment. And then the strategies with Origo, adding a group and subtracting a group. We're going to go to that website and look at the great games and things that they have on there. And I also have a game that's focusing on adding a group and subtracting a group from Origo and resources. Okay, we'll go play. All right, so standards. We're going to talk about fluently multiplying and dividing within 100 and using strategies such as that relationship between multiplication and division, because math and multiplication is all about those relationships. And we're going to be applying the properties of operations as strategies to multiply and divide. So we're really going to be focusing in on some strategies. Okay, so we have used this particular diagram many times, and it's from Pam Harris, and it's talking about the development of mathematical reasoning. You can see that each group is inside the other one, starting off with counting strategies, where students are counting one at a time. In multiplication, you may see kids make 3 groups of 3 and then go 1, 2, 3, 4, 5, 6, 7, 8, 9. So they're stuck in that counting strategy sequence. And as they grow, they move into additive thinking, where they're thinking about bigger chunks of the numbers. They may be skip counting at that point, 3, 6, 9, but they're still counting there. And then moving on to multiplicative reasoning, and that's where we want to get students to. And they are moving in even bigger chunks of the number, thinking about the strategy that we're going to talk about today, adding a group and subtracting a group. Okay, and this particular diagram is from Jenny Bay Williams' book, Math Fact Fluency. And you can see in the top are the foundational fact sets, and at the bottom are the derived fact strategies, and that's kind of where we're focusing today. I'm going to be looking at adding a group and subtracting a group. In the last session that I did, I focused more on the doubling and the break apart. The near squares group is really just a specialized part of adding a group and subtracting a group, so we'll be talking about that strategy as well too. Okay, so the adding a group strategy, it's really great for kids when they're learning their 3s and 6 facts. For example, you're going to start with a nearby 2s, 5s, or 10s facts, because those are our foundational facts, things that kids know before they start doing these derived facts, and then add a group. So, for example, if a kid doesn't know 6 times 7, but I do know my 5s, so I can first do 5 times 7, and I know 5 groups of 7 is 35, and I just had to add one more group of 7 to that 35 to get to 42. And you can see that down below in the diagram using the tens frames. And then the other strategy we're going to talk about today is subtracting a group, and it's especially good with your 9s and 4s. And in Vanderwall and in the Red Book, Developing Number Knowledge, and in the Fact Fluency book, all the research says that that finger for the 9s probably isn't the best strategy to use with kids, but to more think about 10s facts and relating the 9s to subtracting a group from your 10s facts. So start with the nearby 2s, 5s, or 10s facts, then subtract a group. The student might not know 8 times 7, but they do know their 10s facts. So they can find 10 times 7, and that's 70, but that's 2 groups too many. So they have to subtract off 2 groups of 7. And that's demonstrated down there with the 10 frames. Okay, Math Recovery has put out a great video where they're showing virtual learning. And I know we have a lot of MITs, but it's great for everyone to look at and see how you might do some of these things with students remotely, because that's kind of the world we're living in, and we may be living in that for a little while. But they're going to be using Tiles, and here are my Tiles. They are just dots on a paper. There's 2s, and they come in blues and reds, or there's the 3s and the 5s. So students will use those to help them move from counting to additive to multiplicative thinking. So we're going to watch about 10 minutes of this video. The video is actually 30 minutes, and it's great for you to go back and look at, but we're only going to look about 10 minutes today. Here. This one already set.
So now this time we're going to start at just a certain amount, and we're going to keep going forward. So I'm going to start with my 12 here. So if I added 1 strip or 1 group of 4 on, what would it be?
If you added another strip on, it would be 16.
All right. Check. Are you right?
Yeah.
Yeah, you got it. What? Ooh, I went too fast. What if I add 1 more strip on? Then what would I be at?
If you added 1 more strip on, you would be at 20.
Are you right?
Yes.
You sound like you're hesitating. Should I give you time to think, or are you feeling comfortable?
No, I'm good. I was just looking to see if it was 5 strips. 5 times 4 is 20, so.
Oh, those are one of those facts that you have memorized?
Yeah.
Yeah, all right. So we said we had 20. What if I put on 2 more strips?
If you put on 2 more strips, it would be 28.
Okay, so how many strips of 4 do I have now?
You have 8 strips of 4.
And that's how many altogether?
32.
All right, so we're going to do the same thing, but we're going to go backwards, all right? So when we start with all 10 strips of 4, how many are we starting with?
If you started with all 10 strips, you would have 40.
You got it. Well, I'm going to take some away. So instead, we're going to start with 32. So what if I took 1 of those away? Then how many would I be down to?
If you took 1 away from 32, you would have 28.
Awesome. You got it. Okay, so now this time we're going to go forward again, but I'm going to flip them. So you see the 4 that we have there? What if I added a strip?
If you added a strip, you would have 8.
Okay. What if I added another strip?
If you added another strip, you would have 12.
What if I added 2 more strips
2 more strips
of 4?
2 more strips of 4 would be 20.
Tell me how. All right. What if I add another strip?
If you added another strip, it would be 36.
And what if I add the last strip here? How many?
40.
There you go. Nice work. Okay, we're going to go backwards. Are you ready? So we're starting with 40 there. All right. What if I take away a strip?
If you took away a strip, you would, so you start with 40. If you took away a strip, you have 36.
Okay, so let's take that away. So we have the 36 there. All right, what if I take away one more strip?
If you took away one more strip, you would have 32.
All right, and what if I take away one more strip?
If you took away one more strip, you would have 28.
All right, so we're going to do the same thing, but this time we're going to start at just a different number. So if you look there, we're going to go forward, but we're starting with 16. So I have 16 dots under there. If I put one more strip of 4 on, what would I be at?
If you put one more strip of 4 on, you'd be at 20.
All right, what if I put one more strip of 4 on, what would I be at?
If you put one more strip of 4 on, you'd be at 24.
What if I put 2 on?
If you put 2 on, 8 strips.
8 strips of 4, and we said that was how many?
32.
All right, so let's do the same thing, but we got to go backwards, right? So we're going to start with all of our 40, but I'm going to take some away so that we only start with 32 this time. So what if I take away one strip of 4?
If you took away one strip of 4, you would have 28.
All right, what if I took away another strip of 4? If I have 6 groups of 4 hidden under this screen, how could I figure out how many that is?
So the way I would do it, I would do 6 times 4, which would be 24.
Okay, so it's one of those you have memorized. Is there a way we could check it? How could you check it to make sure?
I would do the dots.
Okay, so talk to me about that.
So 6 groups is like the 6 strips. So I'd imagine the 6 strips and then 4 in each. And then I would go 4, 8, 12, 16, 20, and then 24, which would be 6. And then there's 6 strips.
I totally understand. So we had 6 under there, and you were right. Okay, this time, what if I sneak in 8 groups of those 4? All right, so here, we're going to have 10 groups of 4 under here. So how many would that be?
40.
Okay, now I'm going to take 2 away. So if I take, I want you to think about that. Look at them go, right? I'm taking this one group away. I'm going to take the second group away.
So what I would do is I'd do 40 minus 8. And when I do 40 minus 8, that would be both strips together because 4 plus 4 is 8. And then when I do 40 minus 8, I would get 32.
I got that. All right, so let's try something else here. So if I have 5 strips of 4 under there and I add 2 more strips, how can I figure that out? Help me out.
So I know that 5 strips of 4 is 20. And then so you said we would add 2 more. And then when you add 2 more, you would get 28 because you started off with 20. You add 1 strip on, which is 4, which would be 24. And then when you add another strip on, it would be 28 because 4 plus 4 is 8, and you started at 20, so you could just add 8.
I understand. What if I have 5 strips of 4 under the screen this time, and then 4 strips of 4 I'm going to add in?
So when you 4 strips of 4.
Okay, so how many strips of 4 do we have there?
You have.
Hold on here just a second, so we can.
If
see
we
a
started with
different
2
kind
strips of 4, it was 8, right? Right? So I have 6 rows of these 4 dots. How many dots?
20.
All right, what if I just move my screen like that? Is that a way that you can check then?
Wait, I think it's actually 24.
Tell me what you're thinking.
I was thinking it's 24 because in school we did arrays. And also, so there's six, yeah, so it's 24 because you have 4 at the top and then 6 at the bottom, and then 6 times 4 is 24.
Okay.
Because
So how many are here?
there's 4.
So if I go down.
There would be 8.
Okay, keep doing that and see what you find out.
If you went down one more, you'd be at 12. And if you went down another one, you'd be at 16. And if you went down another one, you'd be at 20 and then 24.
You got it. All right. So let's try that again with this one. So what if
Okay. So I would love for anyone to unmute and share any things you noticed or wondered about that video, or anything that you have to add about Tiles or the screening that they were using, because I know a lot of you guys use that. So if anybody wants to unmute and talk about what they noticed or wondered, or what experience you have with Tiles. I'm kind of looking in the chat there. Yeah, it was a great demonstration of how we could do some virtual learning there.
Bonnie,
Yes.
I think it also lets us understand how important arrays are when we're looking at multiplicative thinking, you know, that we don't skip that part, that kids need that visual. And that's definitely proof that, you know, she even referenced back about working with arrays in the classroom. So that's really important that we move that multiplicative, in order for them to get that multiplicative thinking, that we move them to that conceptual understanding, not just going directly to learning the facts.
Absolutely, and the way she distanced the setting, where we start off with seeing the whole array and then covering it, just moving the kids to thinking about things more visually. And so it says Tiles really help the students make that visual connection, screening and flashing. Yes. Okay, great. Okay. So I did make a Jamboard, and I am no expert on Jamboards at all, so that you might be able to do this with your kids a little bit. So we will go to the Jamboard here. And I have my 100 grid array here. So let's say that we are going to think about the multiplication fact of 4 times 3. Okay, so a student may not know 4 times 3, but they may know 5 times 3. So they would take this and they could make that array there, and they would see that it's 3 times 5, and they know that that one's 15. And then they could take off that group and see that they have a 3 times 4 array, which is 12. And then I have a screen here too that you could put on there if you want to distance the setting even more and just have the outline of the array there. So if you were going to do a fact like 7 times 8 or 8 times 7, which kind of trips kids up sometimes, they usually know their double facts, or their double facts come a little easier to them. So you might do a 7 by 7 array. And if you know 7 times 7 is 49, then if you have 8 7s, you'd be able to see that that's 56. And then again, you could cover as much as you want to of it. You can go down the rows like she did in the video, or you can just cover part of the arrays and look at that, what that multiplication sentence would be. So there is a Jamboard L cover that you might be interested in using there. This is what the actual one looks like that you might get if you were a math recovery trained person. And it's just the cutout L there with the 100 grid. Okay. Okay. So I have the Orgo games that I kind of referenced last time. These are great to use with families because there's something to do every day of the week and it builds on each other. So if you go to the Orgo site, and this one happens to be grade 3, week 3, and it starts off with a little video on what the strategy even is, and it's only 1 minute. So they're quick little videos.
What strategy can be used for multiplication facts involving 6?
Try helping students build up from a fact they already know. Use a visual model like this to give them a picture of the quantity. Tell me what you see.
I see 5 sixes. I know this is 30 because I learned it with the use tens thinking strategy.
Yes, so if we know 5 sixes is 30, what is 6 sixes?
That's just another row of 6. 36.
That's right. Now let's try extending this thinking strategy to greater numbers. Imagine you want to buy 6 tickets to an amusement park. What is the total cost?
I know that 25 sixes is 150, so 26 sixes must just be another group of 6. That's $156.
Well done. You have just learned to build up from a fact you know to multiply by 6.
That's great. And I started by seeing a picture of the quantity rather than just symbols.
And seeing that quantity is such a huge thing for kids to be able to move along that continuum of multiplicative thinking. So they get the students have that support of what and the parents of what the actual strategy is. And then they go on, and this one is even more in depth about the count up strategy. So they have another support there for them. And then they have slides that they can discuss the strategy with. So the first day is really just learning about what the strategy is. Then the second day is a game. It's hands-on math, and you can print out these multiplication cards and the game board. And I have this video or this visual on my slides. So you're going to mix up the multiplication cards and turn them over and use your strategies to find the answers there. So it's pretty easy for parents to play. Wednesday is a problem solving one. I might, if I were able to go through those before assigning them to students and think about which ones you'd want them to do, because it's more of a paper pencil kind of thing. And then Thursday is the virtual game day. So you can review the 3's facts on your slide there that they give you, and then play the game That's a Fact. You're going to flip a card and calculate the product in your head, then drag a counter to the game board. And it's really nice because they have everything there for you if your kids don't have counters, or and then they can play with a friend, or they can play with a family member. So it just flips a card. So you're going to figure out 7 times 7. And you may think, okay, I know 7 times 5 is 35, and another 7 and 7. So 49 there. And then it's your friend's turn. And they might know, oh, I know my doubles, 8 and 8 is 16. And one more set is 24. So that is a lot of fun for kids to do, and it's got all the materials there that you need to play the game. To close things out. Oh, yep. Okay. Sorry about that. And then it ends with, after game day, is just a practice page. So you may or you may not want to assign those to students for their practice. Okay, so here is the game that Orgo gives to you. It wasn't downloadable, so I couldn't give you a copy, but you can go in there and print it. And here are the game cards and the game board that come with that particular strategy of the count up strategy. And then they have the countdown strategy with all the same supports. Go in, and it starts with the countdown strategy, and it's just a minute video.
How can I figure out the total cost of 3 shirts?
Try building down from a fact you already know.
Okay, I know 20 by 3 is 60, which means 19 by 3 is just 3 less. The total cost must be $57.
That's right. Try using a card like this to give your students a picture of the quantity. Tell me what you see.
I can see 10 threes and 3 tens. That's 30.
Yes, and if 10 threes is 30, what is 9 threes?
It's just 1 row of 3 less. That's 27.
Correct. So when you use this thinking strategy, you are building down from a known tens fact to figure out a fact involving 9.
That's easy. Thinking strategies make so much sense when we see pictures of quantities.
Okay, so parents have that support of what the specific strategy is, and then they have more support for figuring out what the strategy is, then the hands-on math game and problem solving, and then the Thursday they have the online game. Okay, so students are going to be multiplying by 9, so they're going to be thinking, okay, I don't know 9 times 8, but I know 10 times 8, which is 80, and then 9 less is 72, or 8 less, so they could put it on there. And then their partner could go with the next one. Okay. And like I said, those weren't downloadable, so they're just printable. So there is a copy of what they would look like. Okay, so we're towards the end, and if you want to follow us on Facebook or Twitter and give us any kind of feedback that you would like to, and interact and ask questions and post some things that you're doing. I've seen great things all across the state of Kentucky that you guys need to be posting and sharing there. Okay, and that's me. So if you need anything, feel free to contact me, and I will turn it back over to Kelly. I've never gotten it exactly in 30 minutes before. That's exciting.
I was going to say, you actually almost on the dot, so that's fantastic. We appreciate your leadership, Bonnie, and of course those great virtual games from Orgo. Orgo's a KCM friend. We think they do great work, and so I love that I can pull my counters over there and really have a virtual game. That was fantastic. So now's the time when we ask folks out there to unmute and to talk about the parts of the presentation today that especially resonated with you and or gave you some new thinking about it.
I'm interested in learning more about how to use the Jamboard. If you could give us maybe some written directions or anything on how to do that. I'm better at visual learning to read on my own.
Me too. I need some more training on how to use that Jamboard too. Cindy's kind of our resident expert there.
Jackie, one of the things that's showing up in the chat that some other people, and Amy feels the same way, that maybe our MIT collegial meeting is that we get in there and we work to try to talk about resources like Jamboard and get in there and have I call it a sandbox, when you get to go in and play with it a little bit and work with it. But then we could divide and conquer. There's no need for 97 MITs to go in there and try to make a array board when one of us can make it and share it with each other. So stay tuned. Look, Amy says, heck yeah, we're all in for that.
Yeah,
Just something on our radar.
I created a Jamboard for the disappearing sequence activity I got 2s, and this week it will be 5. So
There we go, Jennifer. Jennifer from Wisconsin, sharing with her Kentucky friends. That's the give. That's the pay it forward part. So
That's right.
thanks, Jennifer. Share that with Bonnie.
Please.
And that makes me happy because it's disappearing sequences. For my counting matters, we got to do it just a certain way. That's awesome. Yay.
And that is the way that that particular video starts off, is with the disappearing sequences. Yeah, it'd be great because those are available for purchase on Math Recovery, but for us to make our own would be great.
Others are saying that they didn't realize some of those good things that you had in there. And of course, we are laying the foundation for how kids see this. So thank you, Bonnie, for highlighting those strategies and giving us really a lot to think about. So people are, yes, Origo is free for certain things. They're a very generous business. They go in there, and especially during this non-instructional time or non-traditional instructional time, they have been doing a lot of that out there. So go take a look. Daily activities, I think that's what Bonnie was in. Bonnie was in some daily activities by the week, some support for parents and educators from across the, actually they're international. They're out, they're traditionally out of Australia. So great.
They have a parent portal for each grade of elementary live at the moment. Yeah.
Yeah, we adore that. Well, Bonnie, we thank you for starting us out with our multiplicative thinking. Everyone says thank you. Remember, this is, we want to make sure you're with us all this week. Okay, we'll have a crescendo on Friday and kind of a, at the end, taking a break from our Zoom session so that we're focusing on our KCM programming. But we'll be back, and we want to thank you guys for being here. Stay out.
Thanks, everybody.
Bye, everybody.